Does
Key value pairs, set of key value pairs is nothing but linked list.
key value? Okay. What do we store in the key? What do we store in the value?
In key, we store a address. In the value, we have the values.
Address of?
Mm,
Previous and the next element.
Previous and the next element. Okay. Anything else? Anybody?
No continuous memory allocation and no random access memory. And here
No
we can
what?
perform more insertion and deletion order. Linked list is not continuous memory allocation. Here we will access random access. We can access the elements randomly. We cannot access the elements randomly here in linked list. And also insertion deletion order is performing in linked list.
Okay. Okay. Great.
It has
Nice.
more methods than a release, like add first, add
add
out.
method like that. Remove.
Okay.
It's a
Fine.
implemented method from the list also and the DQ also. List interface and the DQ. It's implemented method, and it's follow the sub method from the DQ and the unimplemented method from the list interface.
Okay, fine, excellent. So yeah, so linked list is actually part of collection framework, as you already know. It is seen in the collection framework structure, and it is an implementation of linked list data structure. So it's not important to go in deep in the data structure, but linked list means you're creating a list and you are linking the previous element to the next element. So that is why it is called linked list. And it is a linear data structure. That means you can go usually in a singular direction. Okay. So element that are getting loaded over here, they do not load in insertion, maintaining the insertion order from the memory point of view. They get loaded contiguously. That means as an object. So for say if you're adding 7 and then you're adding 8, it's not necessary that 7 is stored in 101 place and 8 is stored in 102 place. So 7 can be stored in 101, 8 can be stored in
Excuse me, if you don't
108
mind,
or
hello? Can you share your screen and
yes.
explain if you don't mind?
I will. Anyway, fine. Whatever you will understand. You can see these pictures, right? I hope this will be able to, you guys will be able to see.
Yes.
Yeah, I think this picture will help. It sounds very difficult and complicated, but it is not. So first say you are in the in this position. Okay, this is a linked list. So A, B, C, D, and E. These are 5 datas that you have added. So these 5 datas are added in a contiguous manner. That means these are the places for the addresses. What do we mean by the addresses? So addresses are nothing but when you're adding a particular type of data, that data is getting stored in the memory, and that memory is getting allocated, right? So that memory will have an address. Where is the location of? So whenever you are trying to get the data of A, it will go to that particular memory location, get the data and show you the result as A. So just like we all live in a house, we have an address. The same way, A, B, C, D, E, all of them will have a particular address in the memory. Just like we have address in our cities. So we live in the city, but where exactly do we live? That address, that particular address. That is stored in here. This is just a pictorial representation. It does not work that in box manner. So if I am adding A, that A is stored per se 108 location. B is stored in 109 location. C is stored in 111 location because it is contiguous, not continuous. So that's why whatever data you are adding, they will be stored as an object and they will have particular address. Am I confusing or somewhat getting?
Yeah, we are getting.
Okay, fine. So first say A is a particular data. Okay, how can I add a, do we add a pen option over here? Saujanya, do we have a pen option over here?
I'm not sure about that, Palamita. I guess
Wait.
it was a external device, I think.
Actual device. I need to buy a pen, you're saying? My God. Uh,
I'm not sorry.
just a moment. I open my OneNote, which is last moment savior for me usually. Yeah, so it's gonna look very weird, but first this is A, and it has another. Let's say it like this. So this is A, okay, and we have another which is B. So usually what happens in linked list, this is an object, this is another object. Okay. This object's location per se 108. And this object's location is 111. This much is clear. The location thing, you're understanding the location, right? If not, please let me know. I will come again.
Yeah, got it.
Yes.
Okay,
We are
okay, fine. So this we mean memory address. Okay. By 108, I mean memory address. So the memory address is nothing but whenever you're adding a particular or inserting a particular data, you will be getting a particular allocation in the memory. The data is getting stored somewhere, right? So wherever the data is getting stored, that address we are getting from linked list. So you have inserted A as a value. The location of the A is 108. You have added B, the location of B is 111. These are the location. Now coming to one more as C. Okay. So let's say C has the location of 119. Okay. So let's say like that. It's happening. Now coming to the node. What is this? What will be added here? If you're trying to create a linked list, this data will be linked to the next data. This data will be linked to the next data. Now how will they link? They don't have hands, so they can't hold their hands, right? They need something with which they will be having the link. So how will they link each other? So A will be linking with B with the help of the memory allocation. So what will A do? A will remember that B is my friend, so I will keep the address of B. So it is keeping the address of B with himself. Okay. B thinks that C is my friend. I will have the address of C. So here it will have the address of C. This way, A is linked to B and B is linked to C. So that is how the linked list happens. So if you want to travel from A's house to B's house, you have to take the address from A's house to B's house. Like you have to understand that 111 is where the B lives. If you want to reach to B, first you have to go to A, ask him where is the location of B. Then he will say that, okay, the location is 111. Then it will go to B. Now, if you want to go to C, you have to ask B the location of C, and it will give you the location of 119, and it will get the location, and it will reach there. So traversing, the data will traverse from one to the other. If you want to reach to C, you have to go like A, B, C. Understandable? Like somewhat. So linked list uses memory addresses to link one object to the other. This is a list. A, B, C is a list. A, B, C is a list. But how are this linked with each other? With the help of the memory address. As you can see, the 111 is the location of B. The 119 is the location of C. Now we don't have a fourth element. So C does not have any address because it's not linked with anybody. Is it confusing? What are the questions that you guys are having? If you are silent, I will not be able to understand what's happening. Please talk.
In the last,
Yes.
what they will store the C means
Yeah.
we don't know
So
the
in
next
C,
address, but
yeah. So C will have nothing. So if you go and check this photo, yeah, you see null. It will have null. This all will have the next node. This all will have the photo of the address of next node. This is the data A. The address will be having the next. B address will be having here. The C address will be having here. D address will be having here. But for E, there will not be any next. So I can't store anything. It will be null. I can add over here null. Okay. So this is how I usually work. Now, if I add suddenly D, I added D after C. So what will happen? The D will have some kind of location. Say D has a location of 145. So what will C do? C will replace the null with 145. Because it has a new neighbor, it will try to have the address of that one. Is it somewhat clear, the linked list?
Yes.
Yeah,
Yes.
ma'am.
Yes.
Yes.
Please, if you're having any question, please get on
Yeah,
with it.
if I want to, yeah. If I want to access an A element, then how can I access that element A with which address? They
With
don't have
which
any.
address you will be? No, whenever you start to like search for something, this kind of linked list that I'm showing right now, they will start from A and they will end in D. Okay, no matter what you're searching. So usually what happens in other array list, how do we get it? We give the index number. We add in, it follows an insertion order, right? For say I'm
Yeah.
giving 1 and allocating it as E, and I'm giving 2, allocating it as Y. Okay. So if I do that, suddenly I want to access the Y. What will I do? I will ask that please get the value of 2 using the index number.
Fine.
Right. Directly it will go to the list. It will go 1, 2, 3, 4 like that, and it will go to 2 and get the value of 2. That is Y. Correct? In
Okay.
array list,
Yeah,
you at
fine.
least have to know something, either the index value or the value. In array list, either you have to know what is the index number. For say roll number we have in school and colleges, right? 1, 2, 3, 4 like that. Either you have to know the name of the student or the roll number of the student. You're suddenly entering a class and asking, I need a student. You don't know anything about that person. You won't be able to get that person. So you either have to know the name or you have to know the index. Now in the same class, you can have multiple names, right? Multiple same names. Just like you know that list allows duplicate values. For say roll number 2 his name is Y. Now you go in the class and search for Y. Both of them will stand up and say, yes, ma'am, I want to go with you. So in that case, what you have to know the roll number, which will be unique to each and every one. But here the indexing is not followed. It does not follow any indexing. If you ask to get the value of C, it will start from here, it will traverse from here to here, here to here, then it will get the value of C. You can't just give the address of C and get it. It's not possible. That's why whenever you're running a program, if you have used linked list, it will take few seconds more. If you use array list, it will take less seconds, because array list use indexing. Understood? Any question from here?
No, we understand.
Fine. Okay. Okay, if you guys have understood 10% of what I said is fine, okay? Because these things will not get into your mind in 1 or 2 days or 1 or 2 hours. It will take a lot of time. So just try to understand whatever I'm saying, at least 10%. Fine. That is mostly about linked list. So one more thing is each element here, A, B, C, everything is known as a node. Okay. Each and every element here is known as a node. Okay. So one more thing is, so when I'm trying to add more numbers here, I'm trying to add more values over here. So I do not have to mention the size of the value, like the size of the list. So how it works? First, you're going to the market, you're adding a list of items that you want to buy. You have added 5 to 6 items. Suddenly, while leaving the home, you suddenly remembered one more item. So you added at the bottom of the list. Okay. So that is possible in linked list. And I guess in array list also, I forgot. So you do not have to mention the size of the list that you want to create. So if suddenly I feel like, okay, I want another element that is E, or let's say G, I want to add another element, I can easily add it. What will happen? I don't even have to worry about anything else. D will automatically get the address node of G. So let's say the address node of G is 167. It will keep the number as 167, so that later part I can access G easily. I can add as many as I want. Suddenly, if I delete this node, this is one more pointer. We do all the operation, creation, deletion, updation, right? So suddenly, if I delete this pointer, this C, what will happen? If I delete it, can anybody please try and tell?
The address
The
will get
145 will replace the 119.
The address of 145 will be replaced with 119.
Oh, sorry, I didn't mean it. The 119 is replaced with 145. On the B, it is 119, right?
On B, it is 119, correct?
Yeah, it will replace 145. That means the B will link the D now.
Correct. No, nice. So now the C is gone. So C is gone means 119 is gone. 119 address is gone. Let's mark it as, instead of deletion, let's mark it as red. This is gone. Let's assume that it is not there. Even we can see it, but it is not there. So what will happen? The B will directly try to connect itself with D, that immediate next data. So what is the address of immediate next data? 145. Now 119 is empty. It will replace it with 145. Now B and D are related. So if you want to go to D, what is the path? A to B to D. That way. Okay. This is how the linking happens using the address nodes usually. Understood?
Yeah.
Okay.
There is
Fine.
no, is there any limit for a linked list, or we can add n number of elements?
No, we can add a number of elements because it's not, you're not allocating anything, right? The memory gets dynamically allocated. If you have memory, you can add. It's dynamic. It's not static that you have added, you have said that the total memory allocation should happen within 1000. If you say like that, it doesn't work that way. It takes the memory allocation according to the dynamic manner. So now C is gone, the memory is filled. So you can add one more data over here. This happens in linked list.
We can't add the element in between that, in between B and D or D and something.
Okay. So the main concept of linked list is there is no between, there is no starting, there is no ending in a manner that we see usually in a market list. So by contiguous, I mean, for say A is here, you're seeing B just right after it. You're seeing C just right after it. You're seeing D right after it and G right after it. In the memory allocation, it is not necessary that we are adding in the middle. It can happen like the A is here in 111. After that 112, 113, 114, there are a lot of things. The B is in 115 here. The D is in 167. So they are not, there is no between, there is no middle, there is nothing like that in here, at least. They are adding they're allocating the memory contiguously in a random manner. But whatever they're adding, they are giving the addresses of it to the previous element. That's what. Understood somewhat?
Yeah.
Yeah. So one more thing is whatever I have taught right now is the implementation of a singly linked list. There are different types of linked lists that we have. This is single linked list. So usually every animal or some, let's say a dog, they will have a head and a tail, right? So this is known as the head where it starts, where uh, the the 108 is not stored anywhere. You can see 108 is not stored anywhere. So this is the head. Okay. And this here is the tail. Simple English. So this is the head and this is the tail. If you add one more node over here for say X or Y, that will become the tail. This will remain the head. So that way this singly linked list works. It is an unidirectional thing. Remember, it is unidirectional because it goes in only one way. This way, unidirectional. Okay. You can see the arrow over here also. Always it stores the data of next, like that. Any question from singly linked list? Whether you guys have understood everything or nothing, I don't know which one, but anyway, this is singly linked list. There are other also like doubly, circular singly, circular singly, and circular doubly. So these four are different types of linked list that we have. Okay, all are following the same concept, that is taking the address of the previous node or the next node. Taking the address is how it links itself. Okay, so singly linked list, doubly linked list, circular, and circular singly and circular doubly. These four types of linked list we have usually. Singly linked list is something that I just explained. Considering the time, I would be able to explain circular singly. Okay, so this two we are keeping for next day. This doubly linked list and circular doubly. Let's go ahead with the circular singly list. So what is circular? Circular means there is no head or tail, right? It's all in a circular manner. Correct? Usually what happens to a circle? A circle does not have any head or tail. Correct? Why is everyone so silent? This is a circle, in case you don't know. Yeah. Anyway, what happened to my Yeah. So this is a circular singly. How it works? So you were saying, somebody was saying that this is null. This is null, right? Because there is no next element in the list. So this value is null. This value is not stored anywhere. 108. Nobody has the address of A. A has the address of B, B has the address of C, but nobody has the address of A. Just remove the confusion from here. Just a moment. Yeah. So now in circular singly list, what happens? Usually the last value contains the address of the first value, thus creating a circle. So 108 is stored over here. That means now G knows where A lives. So there is no head, no tail. If you want to traverse, you can start traversing from any point. You can start traversing from C, D, G, A, B, again C, D, G. This way you can keep traversing. So this is how the circular singly list works. There is usually no head or tail. The last node contains the value, the address value of the first one. Thus, removing the concept of null. There is no address node that has null value. There is no null value over here. Previously, G was containing null. Now there is no null value. So, okay, fine. I will try to clear these things up. Say A has the address of B. B has the address of C. C has the address of D. Don't go so down. Yeah. D has the address of G has the address of D, and this is how it works, like this way. It will create a circular pattern and move in such a way. So if you want to traverse, you have to start traversing from anywhere, any portion you can start traversing, and then you can go ahead. But you have to make sure that you are not in a loop. So how will you know that you are not in a loop? For say you are trying to go to G, or you're trying to find a particular data. You have started from A, you have completed A, B, C, will be a loop. So there is no point. You have to make sure that whatever data you started, it is not coming. If it comes, that means your traversing is completed. It is again traversing. It's confusing, right? Everyone is sleeping. Nice.
No, we are not yet. We are
Then
following you.
when this can stop
We are
traversing?
No, it actually doesn't work like that. If you so if you want to add like find the address of find D, you can start from A, B, C, D. Then it will stop here. Why I'm saying this? Sometimes in the iteration we do what? We do the same thing multiple times, right? We iterate the same thing multiple times. Correct. So that shouldn't happen, or the loop shouldn't happen. So you have to write your loop or iteration coding in a particular manner that it does not, it breaks somewhere. So you have to add a break statement, like if it finds D, then break, like that. Just like you use in loops, for loops, while loops, the
Yeah,
same
yeah.
way.
Okay.
So to break it, that is the way. You have to make sure that it is not an infinite loop. I think you guys have got like encountered infinity loop while coding, right? The console keeps printing and printing and printing unless until you
Yes.
stop the run.
Yes.
Yeah.
Yes.
So that thing shouldn't happen.
No deadlock will happen.
Ah, sorry.
So there is no deadlock like that you are saying, right?
Yes, yes, yes. So I'm saying that previously A was alone. Now somebody cares about A. So G has the address of A. That's what. That's how they're creating a circle. Everybody has something. Nothing is null. So that is circular singly. If you have understood singly, circular singly is also easy to understand. I am very sorry to conclude the session right now. I have a call from 10 o'clock. Surgeon, you have to take over, please. I have the pot sync up.
Yeah, Pulpita, can I continue
Yeah,
from
yeah.
tomorrow? Because I do
Yeah,
need to
whatever
join
you
for
want.
another.
I'll
Yeah.
just drop because I am already 3 minutes late. Sorry. Bye.